Today's lesson is 6.4, Solving Rational Equations. Just a quick reminder that a rational equation is an equation that contains one or more rational expressions. One way that we can solve them is to use cross multiplication. So here's a very simple problem that we use to cross multiply to solve for x. Notice that there is an equal sign in between my two fractions. And this is what allows me to multiply crisscross, the blue times the blue, numerator times denominator, the red times the red, numerator times denominator. Notice that they are setting up an equation and they're multiplying, and then they're going to go ahead and they're going to solve our equation. So they just divided both sides by 30, and 900 divided by 30 is how we got 30. We can apply the same idea to solving rational equations. So here we go. Here's example 1. Solve for u, and we need to simplify as much as possible. So notice on the left side of our equation, we have a rational expression, and on the right side, we just have an integer. Any integer like -6, I can make into a fraction by putting it over 1. Which means I can still cross multiply. So I'm going to do -6 times u equals, and then this one I'm going to do 4 times 1. I'm going to go ahead and -6u, 4 times 1 is 4. I'm going to divide both sides by -6. And I need to simplify as much as possible, which means I need to take this fraction 4 divided by -6, and I just need to simplify it. So it would simplify into 2/3, -2/3. And this would be my answer. Okay, just checking to make sure that that was the end of the slide. All right, example number 2. Notice in example number 2, we have a very familiar cross multiplication problem. So we're going to go ahead and we're going to cross multiply. 15 times x and 6 times x minus 3. Now notice how I did the 6 times the x minus 3. That's because I have to make sure that I do distribute. I do have to make sure that I distribute. So I get 6x minus, because that's what's inside the parentheses, 6 times 3, 18. I would go ahead and I would move the 6x over to the 15. I'm just using my rules of solving an equation at this point, and that gives me 11x equals the -18. I'm going to divide by 11, and I end up with -18 over 11, because that's all it simplifies to. It wouldn't simplify anymore. Okay? All right, if you were in class today, there's a you try right here, and we just went ahead and we cross multiplied. Oops. There we go. We have to remember to distribute this. Minus and minus would become plus. Ooh, no, not 8. What am I doing? 14x. And then we just solve our equation. And that was our correct answer. All right. Let's take a look at this one. So just like the first one that we saw, I'm going to think of -6 as being -6 over 1. I'm still going to go ahead and I'm going to cross multiply. Now, maybe I know I've been doing the blue on the first side and the purple on the other, but I'm going to put them this way. It really doesn't matter. It really doesn't matter. You just have to multiply, and one goes on one side and one goes on the other. Now you might be thinking, why would you do that, Miss? I wanted to do that because it's going to give me negative 48. This way my x was already on the left side, which is traditionally where I would like it to be. I'm going to add my 48. Negative 7 plus 48 is 55. We're going to divide by negative 6. We need to make sure that we are simplifying as much as possible, which means we're looking to see, is there a number that divides into both 55 and negative 6? No, but I would put my negative sign first and then make my fraction. Okay? All right. We need to talk about an extraneous solution before we do our last example. An extraneous solution is a solution to an equation that comes from solving our problem, but is not a valid solution to my original equation. What you need to always do is make sure that you check your solutions by substituting them back into the original equation and making sure that you're not dividing by 0. All we have to do is make sure that we're not dividing by 0. Here is our last question. As I look at it right now, I think, ah! But here's what we're going to do. We are going to find our LCD. We are going to find our LCD. So let's go ahead and let's highlight our denominators. And I need to change the color of this last one. There we go. So there are our 3 denominators. And if I look at the yellow one, I'm trying to think where I have some space. I think right here. If I look at the yellow one and the peach one, they already look like they are what they're going to be. I'm just going to go ahead and put them in parentheses because they already look like a factor. And as I'm looking at that orange one, that dark orange one, I have to factor it. I have to take this dark orange one and I have to factor it. Okay? Now, what you're going to notice, and what many of you might already see, is that y squared is y times y. And some of you might already notice what's going on. 16. Okay, so 1 times 16, 2 times 8, 4 times 4. And I am going to choose the one that would give me 10, which means I'm going to choose 2 times 8 because 2 plus 8 is 10. So 2y, right, when I cross multiply, 8y when I cross multiply. And just like I said, if I add those two together, 10y. There we go. So this is a plus, this is a plus, and take a look at this. What? Do you see it? Those two match. These two match. So my LCD is, I'm just trying to figure out where to put this, you guys. LCD is, there's my LCD. So what I am going to do to solve, because this time they're asking me to solve, they're not asking me to add, they're not asking me to subtract like last time, they're asking me to solve. So I am going to multiply both sides by the least common denominator because that will make my denominators disappear and I will get just an equation. So once again, I'm going to multiply by my least common denominator because it makes my denominators on both sides of my equation disappear and I just have an equation to solve. So I'm going to come right here and I'm going to grab this guy and I am going to multiply this side of my equation times my LCD. And I'm going to do the same thing to the other side of my equation times my LCD. Now here is what is going to happen. It is going to cancel out the fraction on this side. And what I end up having to do on the other side is I end up having to distribute it. So I'm going to multiply my LCD times this one, and I'm going to multiply my LCD times that one. So let me go ahead and show you that. Let me go ahead and show you that down here. So what's going to happen is I'm going to multiply my LCD, okay, times my first fraction, okay, plus my LCD times my second fraction. Oh no. Okay. So I need to come back in here for you guys and I need to erase this because that's really not there. Now watch what happens. This is going to cancel that and my fraction is gone. This is going to cancel with that and my fraction is gone. So what do I have? What do I have here? Well, I have y from my numerator times y plus 8. I have y from my numerator times y plus 8 plus, for my second one, y times y plus 2. Y times y plus 2 equals y minus 16. This is just an equation. I can solve this. I'm going to go ahead and I'm going to distribute the y's for both of these first ones. That's the next thing I'm going to do. Y times y is y squared. Y times 8 is 8y. Y times y is y squared. And y times 2 is 2y. Okay. I'm going to go ahead and I'm going to combine together my like terms. Y squared plus y squared. That would give me 2y squared. And 8y plus 2y is going to go ahead and give me 10y. Oh, wait a minute. This is not a y, you guys. Hold on. Oh, I messed up. This is a 4. Oh, no. Oh, no. Abort, abort. Hold on, hold on. Wait, wait, wait. I was just checking to see how I was doing and oh no. Let's try again. Y squared plus 8y. This is a 4. It looked like a y, but it was really a 4. Let me come back. It is a 4. Oh my goodness. There we go. Plus 4y plus 8. There we go. There we go. All right. So we've got our y squared by itself. We've got positive 8y plus 4y. There we go. And that would give me y squared plus 12y plus 8 equals y minus 16. Okay, so now now that I have everything fixed, I've got to figure out how to solve this. I do not see the y squared disappearing. And the reason I don't is I'm looking at both sides of my equal sign. I see the y squared here, but there is no y squared on this side. So it's not going to disappear, which means I have to factor. I'm going to go ahead and I'm going to subtract this y, and I'm going to subtract it from from the 12y. And I'm going to go ahead and add the 16, and I'm going to add it to the 8 because those are my like terms. I get y squared plus 11y plus 24 equals 0. What I'm going to do next is I'm going to go ahead and factor this. I have to go ahead and factor. So I'm going to look at my factors of y squared, which are, let me see, I can do it right down here, y times y, and the factors of 24, that would give me 11. 11 is what I need. So let's think. 1 times 24? No. 2 times 12? 14, that's close. 3 times 8. There we go. 3 times 8, because 3y plus 8y is going to give me the 11y that I need. So there are my two terms. And what I have now is I have y plus 3 times y plus 8 is equal to 0. My last step, because I am solving, I have to go ahead and I have to do the zero product property. So that was the one that said this factor equals 0, or the second factor equals 0, or both of them. So I just go ahead and set them both equal to 0, and I solve, and I get -3, and I get -8. But remember, they could both be an answer, or or only one of them could be an answer, or neither of them could be an answer because of our extraneous possibility. So what we need to do is we need to go back up to the top, and we just need to make sure that we do not get a 0 when we plug it into the denominators. We want to make sure that we are not dividing by 0, okay? So let's do -3 first. Let's do -3 first. I'm going to check here, here, and here. I just want to make sure that none of those are going to become 0. Now, the nice thing is that this and this are also that. So do I have to check all three? No, because the dark orange is the same as the yellow times the peach. All I have to do is check the yellow. What is -3 plus 2? Well, it's -1. What is -3 plus 8? Well, it's +5. Neither one of those is 0, so -3 is a solution. Let's go back down to the bottom. -3 is going to be one of our solutions. Let's now check -8. Come back up here. Remember, you're only checking this side because the other side is exactly the same. The denominator over here is exactly the same. Remember, that's how we could cross it out. -8 plus 2 is -6. You're just looking to see if you get 0. -8 plus 8, uh-oh, there it is, 0. This is it is an extraneous solution. So this one is extraneous, and we actually would not use it. We actually would not use the solution. And I just want to show you before we leave today why this happened. We put in -8, and we did -8 plus 2, and then we did 4 over -8 plus 8. And so we showed that it was -8 over -6 plus 4 over 0. And this is the one right here. This is the reason right here that we are extraneous. This is what made us extraneous. The 0 right there. Can't happen.